Hello and welcome to video 21 in my Rigging in Maya series. This video was originally going to cover adding the IK and FK controls into the limbs of our dog, but I decided to take another approach. I've covered basic IK-FK blending before, plus I recently released a video showing different quadruped rig configurations, so I didn't want to just repeat myself and take you through things I've already shown before. If you would like to refer to those videos, there are links in the description below. As this is a more advanced section of rigging, I decided that I would instead introduce you to some scripting. So as well as building the IK-FK legs, I will show you how to automate the process. So, over the next few videos, you will essentially be creating your own automatic limb rigging tool. Before we get started, I wanted to mention that you can now download all the source files for this and all my other courses from my QBrush, Coffee, Gumroad and ArtStation pages, so plenty of options there for you. You can find links on the screen and in the description below. I also wanted to tell you about the AntCGI Club. Joining the club is a way for you to help support the future of this channel, as it will allow me to dedicate more time to creating new content just for you. But that's not all. You can also earn yourself exclusive rewards. These include all the course assets, models, rigs and custom-made scripts, as well as access to the members-only area of the AntCGI Club Discord server. You can also now claim a discount on all AntCGI merchandise. There are two ways you can join. The first is to simply click the join button below this video and become a member of this YouTube channel. The second is to head over to my Patreon page and support me there. Alternatively, you can visit the link on the screen or in the description below to find out more. Now I have a bit of a disclaimer here. I just wanted to make a few things clear before we begin. Firstly, this is just one approach to creating an automatic rigging tool. I'm sure there will be more advanced users out there who will watch this video and be asking why I did something when I could just do it another way. The whole point of these videos is to get across the basic principles of scripting, so you, the viewers, can hopefully feel more confident in using Python to build your own simple tools. Secondly, when it comes to scripting, I'm completely self-taught and I'm still learning myself. So if I miss something or I get something wrong, please be gentle. Now that's out of the way, let's get started. So here we have the dog rig, but he looks a little different to the version we had in the last video. I've done two things. Firstly, I added some controls to the scene. Again, I've covered control creation before, and this video is going to be long enough without going over the process again. So I thought I would skip over that part so we can focus on the script. These are basically the controls which are created when you run my auto limb rigging tool. What I've also done is skin the joints to the model. This has only been done for this video, mainly so we can see how the joints are working. As mentioned in the previous video, these joints won't be driving this model directly, so this isn't part of the process. If you want to follow along using the same scene, make sure you download the source files. So at this stage the controls don't do anything to the joints. Let's start by opening the script editor. We can access it through the Windows menu. Here it is. Or you can use the button down here. You can already see that Maya has been tracking what we've been doing to the scene. Up here in the output is a list of our actions. If I select the paw control, you can see here that Maya has given us the mel command which would do the same thing. Again, if I move it, we can see the command used here. So if I copy this bit of mel here and paste it down here, I can use the execute button to run this bit of code, and that's selected the control for us. If we do some other things, like rotate the fibula, everything is logged. So let's have a look at the code. You can see that select is highlighted in blue. This is because it's an actual command. Next to it we have -r, and this is what's known as a flag. Flags are used to control what the select command is going to do. And then we have the name of the object we want to affect. You can see we are working in the Mel tab now, but we will be writing our script using Python. The problem is Maya will output the commands as Mel, but not in Python. But to be honest, it doesn't take much to convert a Mel command to a Python one, as you will see later in the video. So why do we use Python? Well, it's far superior to Mel, and it gives us much more control and freedom in our scripts. With that said, it doesn't hurt to know a bit of Mel too. I started out using Mel many moons ago, so I had to learn it in a way. These days you could just jump into Python without using much Mel, but I would recommend getting a basic understanding of it, as that will then help you when writing your Python scripts. Okay, so we have the select command here, but what else can we do with it? Well, if you go up to the help menu, you will find some handy scripting reference links. Here you have a full list of commands, so you can explore them further. So, let's find select. Here it is. We have all the information on the select command here. What we are looking at is the Python version, but we can easily switch to Mel and back again, depending on what we want to use. If we scroll down, we can see all the flags at our disposal. Here is -r, which is replace. You could also type -replace and use the full name if you wanted. Here you get a description of what the flag will do. So in this case, it will replace the current selection with whatever you specify. Down at the bottom, you will also find some handy examples. In the past, I've simply copied these across and changed some of the names to get me started. It's a good way to learn. If we go back to the Python version, you will see how things differ. The flags are used differently in Python. There isn't the minus. If we go down to the examples again, you will see that the format is different too, but we'll get into that shortly. Now, the Maya script editor is all well and good, but it's very basic. Let me just activate this plugin here. So this is Charcoal Editor version 2. I use it for all my scripting. This is one of the very few plugins I use. There's this and NG Skin Tools. I just find it helps, and it also enhances the scripting experience. It is a paid plugin, but there is a free trial available, so please head over and try it out for yourself. As always, there's a link in the description below. Right, let's start scripting. First, make sure you're using a Python tab or the code won't work. I always start my scripts with a simple header. Using a hash will comment out all the characters after it, and we can see that this has happened here because they've turned green. So here we have a simple box, and I can put text in here so I know what this script will do. I have so many scripts knocking around, knowing what each of them does is essential, so I'm not reading through the code all the time trying to figure things out. You can also add in some simple instructions here too, for anyone else that will be able to view this. So there, nice and simple, and I know what this script is supposed to do. I'm now going to right click and go down to execute. What this has done is run the script, but because all we have so far is commented out, it doesn't actually do anything. This is good because we didn't get any errors, so it shows the hash works. Next we are going to type import maya.cmds as commands. Obviously commands is spelt as CMDS. Now this is important when using Python. What we're essentially doing is telling Maya to import this module. This holds all the Maya commands. We can then use CMDS to refer back to this module and pull the commands from it. Next, we are going to define a function. So type def first to define it, and then give it a name, like AutoLimTool. What this will do is hold all the code, like a folder in a way. This makes it easier to run this piece of code, but it's also better when working on a script. Having everything in a function when working will mean you can undo everything in one go. as you will see. If your code isn't in a function, you could end up having to undo each line at a time. We finish the line with a colon. This indicates that there is a block of code to follow. You also need parentheses at the end of the command too, just like all commands. These can hold other information inside them, known as arguments, which is useful when passing information from one function to another. We can see here there's a red dot. This indicates we have an issue with the code. This is just here to remind us that the function needs something inside it. Let's just add something simple to start us off. Because this code is inside the function, we need an indent. Let's just print some text. Something like that will do. If I execute this now, nothing happens, and that's because we have to call the function. Let's save this first. I'll overwrite this script video21_auto_lim. So now that's saved, I can create the code we can use to add a button to the shelf. This way, we can just use the button to run the script each time we want to test it. First, we need to import the script so we can reference it. Next, I'm adding this so it will reload the script each time we run it. If you don't add this, Maya will use the first script you imported because that's now stored in memory. We reload it to update it each time. Finally, we need to run the function. So we use the script name first, then add a period. You can see now that a list has appeared and on the top is the AutoLimTool function. Select that, and we need the parentheses on the end. If I highlight this bit of code now, and then press enter to run it, you can see above that it's printed, it's working. So yes, this will work. All you need to do now is save this bit of code to the shelf. Now I've already done this here, so I can use this to run the script whenever I want. Okay, we can remove that now it's stored in the shelf. I'll just test the button. There we go, all set up. Okay, let's remove that line. I'm going to add another comment here. It's important to comment your code as much as you can. If you ever come back to this script, it will help you understand what each area is doing. It's also essential if you're going to pass this on to somebody else. So, we're going to start by defining some variables. Variables are containers that hold information that can then be passed to other areas of the script. What these can also do is work like a temporary user interface, so you can define specific things in the script here which will control how the script works. First, let's tell it whether we are working on the front leg or the rear one. These need to be rigged in a slightly different way, so it's important to know which we are rigging. All we need is a name, so call this isRearLeg. Then we will say that this name is equal to 1. So what we can do is throughout the script, check if this is set to 1, and if so, we are working on the rear leg. If it's set to 0, then it's the front leg. We could even add a comment after it to remind us if needed. Next, let's set up how many joints we have in the limb. Now, because we are working on a dog's leg, this will always be 4, but adding this here will give you more flexibility if the joint chain is different. Or if you decide to expand upon this script later, maybe adding the option for a biped limb. We can now start to build some naming conventions, so everything we add is named correctly. What we can do is check which leg we are working on first. I can use a simple if statement to do this. So this will basically check isRearLeg to see if it's set to 1. If it is, it will run the following code. So we can use this to define the limb type. So this is rear. We can also add another print command to make sure it's working. Printing things is a great way to debug the code and make sure the variables are working as they should be. Let's test that now, but I have to save the script first. So it's printed, so that knows we are working on the rear leg now. But what if we are working on the front leg? Well, if the if statement checks is rear leg and it's 0, it will skip over the code inside it. To catch it again, we use an else statement and use the same bit of code to define the limb type, but change that to front, obviously. And change the printed text too. So this will now check if is rear leg is 1. If not, it skips down to the else section and uses that code. Let's change this to 0 and test it again. And there we go, front leg. Change this back to 1. And that's the rear leg. It's quite basic so far, but we are laying the foundations here which the rest of the script will rely on. So this script will work by using a selected joint as the start point. So now let's add in some checks to make sure the user has actually selected something. Let's call this selection check. So this line will look at what's selected and store it in the selection check variable. And here we can use our first bit of mel. So we use commands to reference it from the maya.cmds module. Add a period and then ls followed by the parentheses. I'll just make some space down here. So this is a list command. Another neat feature of Charcoal Editor is the ability to quickly get a list of the selected command's flags. I just right click and go down here to Quick Help. Now we have a list here of all the flags available, so we don't need to go digging into the scripting reference. What I want is to list the current selection. So here, -SL. While we're here, let's quickly look at the select command we were using earlier. You can see here the replace flag. So that would be -R if it were mel. But we're using Python, so instead it needs to be R equals 1. So you need to keep that in mind when using flags. Okay, so we wanted to get the selection, which would be -SL. So in Python, that's SL equals 1. If I highlight that now and run it, you see the result is empty because we have nothing selected. Let's select the femur joint and try again. There we go. And if we had more than one thing selected, it would give us a list here. What this will do is store everything that's captured by the list command in the selection check variable. This means we can then do things with the list. What we can also do as an extra precaution is use the type flag and specify that we are only interested in any joints that are selected. Let's add a few controls to the selection. And run this. You see it's only returned the joint. Okay, now we have a way of looking at what's selected. Let's do some checks and output some errors if it's not what we need. I'm going to use an if statement again, just like we did earlier, but this time I'm following that with an operator. This one is not. So what we're doing here is checking to see if selection check has anything in it. If not, then run the following code. So at this stage nothing is selected, so we can use another mel command, error, to tell the user to select something. Simple as that. Let's test that now. So nothing's selected. Press the button, and there we get an error. It's output here too. So what do we do if there is something selected? Okay, let's use else again. What we can do is use another variable to store the root joint's name. Again, so we can use it later. And we can use the same bit of code to get the selection. Let's select some joints and give this another try. Actually, let's print what's stored in root joint 2. So there we have the 3 selected joints, which is great, but we only really need the first one. All we need to do is add 2 brackets with 0 inside to the end of the list command. What this will do is only return the first item in the list. If we save and run that again, you see just the femur is returned. We use 0 because all lists in Python begin at 0. They then go through the numbers 1, 2, 3, 4, etc. So if you wanted the third item in the list, you would use number 2. It's a little confusing, but you get used to it eventually. Let's get rid of these. Now we're going to make this script a bit more economical. We're going to check what the prefix is on the joint we have, and then we know if it's the left or the right side. This can then be useful in a number of ways. The main one will be for building names. So first, we need to get the prefix from the selected joint. Create a new variable and call it which side. First, we can set this to be the same as a root joint, which is the selected joint's name. As it stands, this won't work because we don't want the full name, we just want the first 2 characters. Just as we did earlier, we can use brackets to dictate what we need. So add the brackets, not those, the square ones. Inside, type 0:2. If we just had 0, this would just return the first character. So we need the colon and the 2 so we can get the first 2 characters. Again, we can use a quick print command to check that what we are getting is what we need. You see, that works. It's given us L_, which is perfect. Obviously, this depends on the name of the joint, but if it's named correctly, then this will work. Actually, let's add in a check to make sure the prefix is in the name. And again, we can use the if statement and use the not operator again, but this time check that the prefix is in the name. So we use if not L_, in which side, colon. Basically, if which side doesn't have L_, do the next thing. So next we can repeat the same line, but check if it's actually the right side prefix. If we get to this stage and it doesn't have L_ or R_, we can throw up another error, so the user knows to name their joints correctly. Okay, let's test it on a joint without a prefix, like the root joint. There we go, it's given us an error. It's important to put checks like this in your scripts or the user will end up with errors and have no idea what's caused them. So that works, and we have also stored the prefix, so next we need to build some names. Because we already have controls in the scene, we need to tell the script which ones to use. Ideally, you would build the controls as part of the script, so you would already know the names because you specified them earlier in the script. Again, this could be part of the UI if you wanted, kind of like how I've approached things with my IK-FK matching script. First, let's build the limb name. This will start with the prefix, which is which side. We can then add leg to this, and then finish with the limb type. So this name should be L_leg_rear. Let's print this to test it again. Hang on, we want to print limb name, not limb type. There we go, left leg rear. Now we have that, we can add in the control names. You should try and match the names of the controls you are using if you're not using this same scene. So for our main control, we need limb name and then _control on the end. I can select the control to check that that's the correct name. That's fine. The paw control is almost the same, although we also need IK in the name. I'll select it to make sure. Yep, that's right. Next we will add the knee control, which we need for the pole vector constraint. Actually, I'll add the name to these too. So the knee needs tibia in the name. And we can also add the hock control too. So this needs hock in the name. And finally, the root control. That's this one here. Remember to check these against the control names. If they aren't correct, you will get an error later in the script. Now we have all the variables set up, we can actually start building something. But first we need to find out what the rest of the leg joints are called. I might add an extra divider here to indicate a new section. We have our root joint, which is the joint that's selected initially. So now we need to check the rest of the hierarchy. Let's store this in joint hierarchy. This time we need to use a different list command, and that's list relatives. What this is used for is finding the parents and children of the specified object, so we can use it to list the joints in the leg. You see, we have all the flags here we can use. We need to add the joints we want to use, so let's use the joint root. If we run just that bit of code now, we get a small list. You can see it's returned some of the joints, but not all of them. So we need to use a flag. To get all the children, we can use the all descendants flag, or AD. Now we have a much bigger list, which has all the leg joints. Again, as a precaution, we can use the type flag, so this only returns joint names. The problem with this list is it isn't actually a full list of joints. All this has done is list all the children under the femur joint. So you can see this isn't in the list. The first joint is in fact the fibula. We need the joint you selected first to be in the list too, so we can use it in the script. Again, this is easily done using Python. We just use the append command and add it to the joint hierarchy list. If we add the root joint inside the parentheses, it will add this to the end of the list. Okay, let's check that. If we look at the end, femur is now part of the list. This gives us a full list of the leg joints to use. The next issue we have is the list is backwards. For us to use it, it would be easier if the joints were listed in order, from the femur onwards. Again, we can easily swap things around. This time we can use the reverse command, and that will simply flip the list for us. With commands like append and reverse, you have to add them onto a list for them to work. Let's run that again, and that's flipped the list. Now it's time to start building some joint chains, but before we do, we need to clear the current selection. You have to do this because if you have a joint selected, when you create a new one, it will be automatically parented to the selected one, which we don't want. We can use the select command again, and this time simply use the CL or clear flag. Now let's build some joints. For this to be a successful limb, which will blend between IK and FK and also be stretchy, we need some joint chains to work with. Because we spent the time doing all the preparation work, this shouldn't take long. First, we need a list of the joint chains we need to create, but this can also help us to rename the new joints too. Because this is a list, we need to put them into brackets. We need 3 names: IK, FK, and stretch. We can add these onto the end of the new joint names. If this is the rear leg, we need to add an extra driver joint chain, but we can easily check now and add that to the list if needed. Just like earlier, we can use the ifIsRearLeg variable. If it is, we can use append again to just add driver to the end of the list. Now let's build the joint chains. What we are going to use this time is a for loop, which looks something like this. The new joint name can be anything you want really. It just indicates each item in the new joint list. What a for loop does is it goes through the list, each item at a time, and runs the following code. Let's go back to the beginning for a second. If you remember, we added the limb joint variable here and set it to 4. This was to match the main joints in the leg because we only need those. We want to ignore the toes. We can use this to limit the amount of joints we create in each joint chain. To do this, we can create another for loop, but this one's a little different. Instead of working through a list, like we are above, we want to go through the code a specific number of times. So we use I in range this time, and inside the range parentheses, we could add a number which would be the amount of times the following code is run. Instead, we'll use limb joints, which currently represents 4. This way we can update this at the start of the script to make things more flexible. The I simply represents each number inside limb joints. So when the loop runs, I will be 0, then on the second run I will be 1, on the third run I will be 2, and so on. This will be ideal for our script because it means we can go through each joint in the list in turn. First, let's create a name for the new joint. What we can do is use the joint hierarchy list, but if we use brackets and I, we can reference a certain joint in the list. Because this is the first time in the loop, it will find the first joint in the list. On the second run through, it will pull out the second joint in the list, and so on. You hopefully get the idea. We also want to make this name unique and show what this joint is used for, so we can use new joint. This will add either IK, FK, stretch, or driver from the new joint list variable to the end of the name. Because this is from the first for loop, it will use a different item in the new joint list each time. Right, we've gone over quite a lot there, so let's just run it and print the joint names. Okay, an error. I fell for one of my own rules. I didn't select a root joint. Okay, another error. Looks like I have my name spelled incorrectly. I missed the capital L. That's better. Names are really important when it comes to scripting. Okay, there we have all the names of the joints listed. So for each item in the new joint list, we have 4 joints. For IK, for FK, for stretch, and because we are working on the rear leg, 4 driver joints. And because we used the second for loop, we were able to reference the first 4 joints in the joint hierarchy list. I hope that made sense. So now we have the names, and we have the loops set up and working, we can now create the joints. We can use the joint command this time to create a basic joint. Let's bring up its flags. The first thing we should do is make sure the joint is named correctly. And we have just spent some time building the names, so we may as well use them. -n is the flag we should use. So if we convert that and add the name, we should add n equals new joint name. This is going to create a new joint with the name we built here. The new joint will be at the world root, so now we need to make sure it matches the position and orientation of the main joint. This time we will use the match transform command. Let's add in the name of the new joint first, and next we need to add in the name of the joint whose position it will be matching. So we can copy joint hierarchy from here, as that already specifies that joint for us. We have to add a comma between our flags or names. Okay, so this will create a new joint for each one in the leg and then move it to that position. Let's give this a try. I'll just move the outliner over so we can see what's been created and if it's worked. We can see that something has happened because we have some new joints in the scene. As you can see here, it's created the joints, but it's added them all into the same hierarchy. So this goes back to what I mentioned earlier, and that when creating joints, they will automatically parent themselves to the selected joint. Plus, if I just move this, you can see that we have rotations on the joints too, so we need to remove those. Let's undo this. So all we're going to do is freeze the transforms on the joint after its moved position. To do this, we use the make identity command. So this will do the same as if we went up here and did it manually. Also, just to mention, the match transform command is the same as using the match transformations tool here. We need parentheses and the name of the new joint we're creating. We are going to use the flags A-1. The next one represents translations, rotations and scale, so all we need are the rotations to be frozen. We don't need to print the name anymore, so we can remove that. Now we need to fix the hierarchy. All we need to do is clear the selection, so we can use the same code we added earlier. What we have to be careful of is when it's cleared. If we add it here after the make identity command, every joint that's created will be on its own, whereas we need each separate limb to be a full joint chain. So what we can do is drop this back so it will clear the selection once the full leg has been built. Adding it here means it won't be called until 4 joints have been created. Okay, let's try this. There we go. We have our 4 main joint chains. Plus, there are no rotation values on them. Perfect. We should check each joint just to be sure. All good. That's the base joint chains built. With those done, I think it might be a good time to take a break. We have a lot more to cover, and this video has run for quite a while already. So we will investigate adding the systems which drive these joints in the next video. Well, we've come to the end of another video. Thanks for watching right to the end, and if you found this video useful, please hit that like button to show your support. While you're at it, you could also subscribe and enable notifications so you're kept up to date with future videos and community posts. If you have any questions or suggestions, please post them in the comments below, or contact me through the AntCGI Club Twitter account and I will try my best to reply. Alternatively, you could post them in the AntCGI Discord server where I spend more of my time. You can find an exclusive invitation to join in the description below. Remember that you can also join the AntCGI Club to help support future videos while also earning yourself exclusive rewards. Alternatively, if you would just like to show your appreciation, why not treat me to a coffee at my coffee page? The link is on the screen now and in the description below. Thanks again, this is AntCGI signing off, and I will see you on the next one.